Let's talk about two-dimensional shapes and their areas. We're looking at 6 of the two-dimensional shapes, and we're going to start with the circle. The circle's area formula is area equals pi r squared. We have to use pi, which is a value. We often use 3.14, a rounded off version of pi, as our value in problems. And we have to know what the radius is. R is the radius. It is the distance from any point on the outside of the circle to the exact center of the circle. Next, we look at the triangle. Its area formula is base times height over 2. The base is any side that we wish to place at the bottom of the triangle to tell us where our height is. The height can go up through the middle of the triangle, or it can be a side of the triangle, depending on the type of triangle you have. Here I'm showing an equilateral triangle and a right triangle, and there are other types. Next, we look at the rhombus. The rhombus is like a square in that it has 4 equal sides, but it doesn't have to have right angles on the inside. To use the area formula of a rhombus, we have to know the big D and the little d, which are the diagonals of the rhombus. I'll show them here. The big D is whichever one of them is longer. The area formula, big D times little d over 2. And now we look at the trapezoid. The trapezoid comes in different styles as well. Here I have an isosceles trapezoid and a right trapezoid. The area formula is big B plus little b. The total is multiplied by the height and divided by 2. Here I'm showing where the big B, the little b, and the height are for 2 different types of trapezoid. Looking at the square, the area formula for a square is area is equal to side length squared. Well, all of the sides are the same on the square, so if we only know one of them, it means we know all of them. Now let's look at the rectangle. Rectangles also come in different shapes. There are skinnier ones and wider ones. The area is equal to the length times the width. The length is one of the sides, and the width is another side that is perpendicular to the length. You don't have to consider the longer side to be the length. They're interchangeable. These are some of the more common two-dimensional shapes and their area formulas. If you know the key features of each shape, it becomes easier to use the formula.